everyone, let's go ahead and get started with this review on chapter 7 or section 7.1 through 7.4, rational functions, inverse functions, multiplying and dividing rational expressions. Okay, so first thing I want to say, when you're taking this test, please make sure that you're reading the instructions. Make sure you know what they're asking so you don't do too much, you don't do too little, and you show work when that's required. Okay, all right, so on number 1, we are going to be using long division to rewrite something that is in standard form in simple form. All right, so our divisor is going to be x plus 2, and our dividend is going to be 6x minus 1. So we have x plus 2 and 6x minus 1. All right, to find the quotient, I'm asking x times what would make 6x? So x times 6. So 6 times x gives me 6x. 6 times positive 2 gives me positive 12. Now, just like we do in long division, we subtract these two polynomials. 6x minus 6x, well, that cancels out. Negative 1 minus positive 12 gives me negative 13. That becomes our remainder. So when we write this in simple rational form, we can start with our name of our equation, which is g of x. You could also put y in place of g of x. So g of x is equal to negative 13 over x plus 2, and then our quotient, plus 6. All right, part 2 of this equation says describe the graph of g's transformations from the graph of f of x over 1 of x. That is the parent function. We talked about that the very first day that we started this unit. But just talking about those transformations, what does the negative mean? So when I'm looking at this, what does this, well, let me write on that. What does that negative for the 13 mean? That is a reflection over the x-axis. So reflection over x-axis. All right, next thing, what does the 13 represent? If it is between 0 and 1, it is a compression. If it is just 1, it is neither a compression or a stretch. If it is greater than 1, which 13 is greater than 1, then it is a stretch. So this is a vertical stretch by 13. Keep in mind that the negative does not make it between 0 and 1. The negative has it reflect over the x-axis. Okay. Then I have x plus 2 in the denominator. That is a horizontal shift. And that one is going to go left 2. And then we have our k value over there, or the vertical shift. And that one is going to go up 6. All right, those are all the transformations. Now write the equation of the asymptotes. What's important here is it says write the equations. Equations means there needs to be an equal sign. This is not just a number. The vertical asymptote crosses the x-axis, so this is going to be x equals. We get that from the denominator, so x is going to equal negative 2. The horizontal asymptote is the y value. In this case, that equals the, or pertains to the k, or that constant, so y equals 6. Now we are going to be looking for the intercepts. We got to show work on these. We have to show work to get the credit. We're going to be looking for the x-intercept and the y-intercept. When we want the x-intercept, we don't want y, so y becomes 0. When we want the y-intercept, we don't want x, so x becomes 0. Okay, that's what it is when it crosses the x-axis or the y-axis. So let's go ahead and start with these equations. So on the very first one, to find the x-intercept, you can use either the rational form or you can use simple rational form when you're figuring this out. I'm going to go ahead and go with the simple rational form because that's what we practice most in class. So y is going to be 0, so we're going to have 0 equals negative 13 over x plus 2 plus 6. Subtract 6 from both sides. So I will have negative 6 is equal to negative 13 over x plus 2. Okay. Now we're going to go ahead and cross multiply these so that I can get negative 13 by itself for just a minute. I can get it to this form here. Oops, don't want to write that there. Negative 6x minus 12 equals negative 13. Add 12 to both sides of the equation, so we get negative 6x is equal to negative 1. Divide both sides by negative 6, and I get x is equal to 1/6. So our x-intercept is 1/6, 0. Now to get the y-intercept, instead of replacing x with 0 or y with 0, we're going to replace x with 0. Again, I'm going to use a simple form. So I'm going to have y is equal to negative 13 over 0 plus 2 plus 6. So that gives me y is equal to negative 7.5 plus 6, which gives me y is equal to, oops, that's negative 6.5, not negative 7.5, so sorry about that. Let's go back and correct that. Negative 6.5 plus 6, and that gives me y is equal to a negative 0.5. Because my last answer was in a fraction, I'm going to turn negative 0.5 into negative 1/2, just so I keep them both fractions. But you could write it as a decimal as well. Okay? All right. Now, that's it for question number 1. There's 4 parts. That type of question, you would need to make sure that you read the instructions for each part, even if there's 5 parts or 6 parts or 1 part. Make sure that you're reading those instructions. All right, let's go ahead and go on to number 2. So for part number 2, we are going to be graphing the function, making a table, state the asymptotes, the intercepts, make sure we show work, the domain, and the range. Okay, so the very first part, notice whether this is in standard form or in simple form. This is in simple form, so we don't need to use long division to change it. Okay, the vertical asymptote is x equals positive 1. Horizontal asymptote is y equals positive 4. When we're making our table, we're going to go to that center box and we're going to write the vertical asymptote value here to help us out. So it's 1, 2, 3, 4, and then 0, negative 1, negative 2. Remember that the vertical asymptote is a line that, or a part on the graph or a line on the graph that the graph never touches, or I should say on the coordinate plane that the graph never touches. So that one is going to be undefined. Okay, we are going to use our calculator for all of this. We're going to take negative 2 and replace the x value with that. We will then do that again with negative 1, 0, 1, 2, 3, and 4. Now, negative 2, when I plug that into the equation, we're going to get out a decimal for that one. We're going to get out 2.3 repeating. When I plug in negative 1, I will get my output as 1.5. When I plug in 0, my output will be negative 1. If I plug in 1, my calculator should give me error undefined. When I substitute in 2, I will get out 9. Substitute in 3, I will get 6.5. And when I substitute in 4, I will get 5.6 repeating. All right, to find the x-intercepts, again, to find x-intercepts, we're going to make y 0. When I want to find the y-intercept, I'm going to make x 0. Okay, so let's start with the x-intercept. I've got 0 is equal to 5 over x minus 1 plus 4. Subtract 4 from both sides. Then cross multiply. Or you could multiply both sides by x minus 1. It gives us the same thing. So I've got negative 4x plus 4 equals 5. Subtract 4 from both sides, so I will have negative 4x equals 1. Divide both sides by negative 4, and I get x is equal to negative 1/4 or negative 0.25. I'll do decimals this time since I did fractions last time. So the x value, negative 0.25 comma 0. All right, let's go ahead and find the y-intercept. Y-intercept doesn't have as many steps, so I've got y equals 5 divided by 0 minus 1 plus 4. So y equals negative 5 plus 4, and that gives me y equals negative 1. Now, I could have saved myself a little bit of work here if I would have looked at the table first. So let me explain how. When I'm looking at the table and I look at the x values and the y values, if there is a 0 in either of those columns, then my x or y intercept was already done for me. So for example, there's 0, negative 1. So I know that has to be my x-intercept or my y-intercept. So 0, negative 1, since x is 0, that makes it the y-intercept. It's the same value that I have here. If I would have just checked my table first, obviously I did that on purpose, but if I would have checked my table first, I wouldn't have had to do this work here. Okay? All right, so the domain on this one is going to be from negative infinity up to 1, because it approaches 1, union 1 to positive infinity. The range, talking about the y value now, as low as it goes is negative infinity. It approaches 4, union, and then on the other side of 4, it goes to positive infinity. Okay, I'm going to go ahead and write down the set builder notation because we did talk about that briefly in a couple of the classes where we've got x is an element of all real numbers such that x cannot be 1. For y can be an element of all real numbers, which means it can be any number, except or such that y cannot be 4. Okay? All right, looking at number 3 through 5. Oops, I didn't graph that. I guess that's kind of important because that was one of the things that it said, that in the instructions, graph the function. So x equals 1. Let me go ahead and zoom in on this. X equals positive 1. Y equals 4. Those are our asymptotes. Make sure that you label these. If you don't label these, you will be losing a point on those. So make sure that you label those. Our points, negative 2, 2.3. Negative 1, 1.5. 0, negative 1. 1 is undefined. 2, 9. 3, 6.5. And 4, 5.6 repeating. Okay. Now I can also graph the x-intercept at 0, negative 0.25. Okay. All right, so when we draw these, remember they can approach the asymptote, but we'll never touch or cross that. Make sure that you put arrows on both ends. Okay. All right, that will be it on that one. And then now let's go on to questions 3, 4, and 5. All right, our instructions say determine if x and y show direct variation inverse variation, or neither. Right, so I want to look at these, and I'm going to go ahead and get y by itself just to make sure I'm looking at it correctly. Direct variation shows multiplication between a constant and some variable. Inverse variation is going to be shown through a constant divided by some variable, and neither would be if neither one of those exists. So for number 3, I'm going to go ahead and get y by itself. So I'm going to multiply 9 times both sides, or go ahead and cross multiply. So I have y is equal to 9 times x. 9 is the constant, x is the variable. This one here is direct variation. Multiplication is direct variation. For number 4, on this one here, I'm going to go ahead and divide both sides by x. So I've got y is equal to 12 over x, this time with division. This is inverse variation. Our constant is 12. And the constant can be denoted by the variable k or a. In our class, we use a. All right. Number 5, remember this is a positive 4 being added to y. So I'm going to go ahead and subtract 4 from both sides. So I will have y equals x minus 4. X minus 4 is neither multiplication or division, so this one here is neither. Okay, that's only with multiplication or division that we're doing direct or inverse, right? Okay, let's go over to the back side. And let's look at actually solving some that are inverse or direct. Okay, all right. The variables x and y vary inversely. That is with division. Write an equation relating to x and y when x is 5 and y is -3. So if we're starting with y equals some constant divided by some value, let's see, they tell us that y is -3. They don't tell us what the constant value is, but they tell us that x is 5. So to find the a value, I need to multiply both sides by 5. So we get a is equal to -15. So when writing that equation, I've got y equals -15 over x. All right, for part B, now find y when x equals -35. So for x, we're going to substitute in -35. So I've got y equals -15 over -35. A negative divided by a negative makes a positive. They're both divisible by 5. So I get y is equal to 3/7. All right, looking at number 7, the time in minutes, which is t, required to empty a tank varies inversely. That's going to be a division with the pumping rate r. The rate, or in gallons per minute, the rate of a certain pump is 70 gallons per minute. It takes the pump 30 minutes to empty the tank. Write the inverse variation equation. Oh, there's inverse again. So we've got t. Well, I'm going to start with what we originally started with. Y is equal to a over x. That's inverse. So we're looking for time. So if we're looking for time, that's going to be our total. We don't know the constant amount. And then x is going to be replaced with r for rate. Okay. So they tell us that it's 30 minutes is equal to some unknown value at 70 gallons per minute is the rate. So let's go ahead and get what our a value is by multiplying 70 to both sides. So we get a is equal to 2100. Now to write the equation, we've got y equals Nope, not y. See how typical it is that we use y? T equals 2100 divided by the rate, whatever the rate is. That's the equation that we're creating. Now in part B, now they want us to find it. So if the pumping rate changed to 50 gallons per minute, that's the rate is now 50. How long would it take? That's time that we don't know for the pump to empty. So now we don't know the time. We know that our constant is 2100 and we know that the rate is 50. 2100 divided by 50, that gives me 42. This is a word problem, so it deserves a word answer. So this will be 42 minutes. It will take 42 minutes for it to empty at 50 gallons per minute. Okay? All right, number 8. Simplify the expression, state the restriction. So we've got to state those excluded values as well. Now, since there's only one term, I'm going to go ahead and get started with stating the excluded values now so I don't forget anything when I start reducing stuff. So I have the variables x and y in the denominator. So x cannot equal 0 and y cannot equal 0. Since it's only multiplication happening, anything times 0 will always be 0. All right, now to go ahead and reduce that, 16 divided by 24, they can both be divided by 8. If I divided them by 2, that would be okay. I would just have to do it again to reduce them further. Okay, so I just noticed that they're both divisible by 8. 16 divided by 8 is 2. 24 divided by 8 is 3. X to the 5th divided by x to the 1st. I subtract those. That'll give me x to the 4th in the numerator because there was more x value, or it's a higher degree in the numerator. And the denominator will be y to the 6th because there's a higher degree with y in the denominator. So for the simplified expression means there's no equal sign, be 2x to the 4th and 3y to the 6th. All right, next one, question number 9. Multiply and state the restrictions. Answers must be simplified in the numerator and denominator. Here it says to write in standard form. I'm going to show you factored form and standard form because factored form is what we mostly practiced in class just to get these identified. But I'm going to show you what they both are. All right, first off, let's go ahead and simplify or factor these. Was one of the things that we looked at here. I looked at the numerator of the first part. They have a GCF of 4x. So I've got 4x. And then I have x minus 2 in the parentheses. The denominator, they can both be factored by 4. So I've got 4 and left with x minus 3 times, this is a trinomial where a is 1. So when I factor this one here, okay, remember we can use those strategies that we know about how to factor these trinomials. We're going to get x minus 3 and x plus 1. And it wouldn't matter if it was x plus 1 and then x minus 3. Well, we talked about that. Order doesn't matter there. All right, now, because they're being multiplied. If it was division, it would matter. All right, now x squared minus 4. This is a difference of perfect squares. X squared is perfect square, 4 is a perfect square, and they are being subtracted. So I'm going to have x plus 2, x minus 2. All right, now that it's factored, I'm going to go ahead and look for my restricted values because I want to make sure that I don't miss those. So I've got that x cannot be positive 3, x cannot be negative 2, and x cannot be positive 2. Okay, now I'm going to go ahead and reduce those that are alike. So 4 divided by 4, that reduces to 1. X minus 2 divided by x minus 2, that reduces to 1. X minus 3 and x minus 3 reduces to 1. So in the numerator, we are left with x times x plus 1. And in the denominator, we are left with x plus 2. This right here is factored form. If you gave me that, that would be correct. Okay, now I'm going to show you how to write this in standard form as well, just so you remember what to do when you see this. We are just multiplying these back out. So x times x gives me x squared. X times 1 gives me positive x. In the denominator, we have x plus 2. That there is standard form. Okay, if you gave me that, that would also be correct. Okay. Either one of those, just read the instructions. Know that if it says factored form, give me factored form. Or standard form I would take as well. But if it says standard form, then you've got to give me standard form. So make sure that you're reading those instructions. All right, let's go on to number 10. So for number 10, we are going to multiply these and state the restrictions. Okay, the answer must be in simplified form with the numerator and the denominator. And again, we're going to have written in factored form, but you can also see that standard form can be written. All right, so let's go ahead and look at these. All right, first one's a trinomial in this numerator, so I'm going to go ahead and factor that. So with this one, I know that it can be factored into x plus 2 times x plus 6. What two numbers multiply to 12 and add to 8? In the denominator, again, that is a trinomial. So I've got x plus 6 and x minus 1. Now, I'm not going to turn it to multiplication yet. For those of you who are comfortable with that, you can do that. Okay, I'm going to leave it for division, and I'll change it in the next step. The numerator on this one is a trinomial that is factorable. So I'm going to have x minus, let's see on this one, x minus 5 and x plus 2. In the denominator, these two here have a GCF of 4x. And I am left with x minus 1. Okay, I'm going to go ahead and list the restricted values so I don't forget them, the ones that are in the denominator. So I have x cannot be negative 6, x cannot be positive 1, and x cannot be 0. Okay, I've got the first one from right here, then one from right here, one from right here. This one is also x equals positive 1, but we already wrote that down once. We don't need to state it twice. Okay. All right, now I'm going to go ahead and turn this into multiplication. Keep the first fraction the same. So x plus 2, x plus 6, all over x plus 6, x minus 1. Now change division into multiplication. That's how we divide fractions. And then we've got 4x, x minus 1, because we flip the second fraction. We invert it so that we've got x minus 5 over x plus 2. All right, almost done. This last step, we're going to go ahead and reduce these. So let's see what we've got. X plus 2 and x plus 2 reduced to 1. X plus 6 reduced to 1. X minus 1 and x minus 1 reduced to 1. So we are left with 4x and x minus 5. This one here is actually in standard form because there's nothing we could have multiplied if it was in factored form in some other, if it looks some other way, other than multiplying 1 by it. So this one here, when it says write in standard form or factored form, there was nothing to distribute. So this one would be 4x over x minus 5. All right, that is it for our review. Let me know if you have any questions.